So let me introduce this symposium. Thank you for all for attending. Today we're going to talk about new regulations, methods, and resolving concerns. We have an excellent lineup of speakers, most of whom will introduce themselves as they begin their talks. And if not, I will introduce them. We're going to talk about regulations. We're going to talk about the physiological benefits aspect of it, and we're going to talk about methodology, and then we'll talk about the legal aspects that are involved here. Our first speaker will be Paula Trumbull, and she's with the US FDA, Office of Nutrition in College Park, Maryland. And she's going to talk today about labeling of dietary fiber. Paula, go ahead.
Okay, thank you. So you can see my slides okay?
Yes, we can.
Okay, great. So, well, thank you all for inviting me again. I presented last year at the 2016 annual meeting, and I'm glad to be back to give a progress report at your 2017 annual meeting. So what I'll be doing is talking about the definition and labeling of dietary fiber. And let's see, this is not advancing. Hang on just a minute. I think we're going to get the advancing mechanism to work. Okay, is that? Okay, now I can advance. Okay, so if you remember a year ago, May, we released the final rule to update the nutrition facts and supplement facts label, as well as serving size. That was a separate rule, and so that was published in May of 2016. And so there were many amendments made to the nutrition and supplement facts label, and many things did not change. And so even though those are two separate regulations, the amendments were made into one single final rule, and then serving size was a separate final rule. So amongst the many changes that were made to both 21 CFR 101.9 and 36 was to provide for the first time, a definition of dietary fiber. And that's in section C6 of 101.9. So there were a number of things, as I mentioned, that were amended. Much of it had to do with the format to increase the font size for calories, update the daily values, mainly coming from the Institute of Medicine, IOM, DRIs, adding added sugars as a double indented nutrient, and adding new and removing some of the old mandatory vitamins and minerals. And one thing that you don't see, but it has been a big change, is the dietary fiber. It still looks like dietary fiber on the label, and most consumers may not even notice that the amount would change if it were to, depending on if the rack for that particular product would change as well. So, as most of you all probably know, up until recently, FDA did not have a definition for dietary fiber. It was just totally relying on analytical methods to measure total soluble and insoluble fiber. And so for that reason, it was not real clear, since fiber, some of us don't believe to be an essential nutrient, and therefore has beneficial health effects, and actually was the basis for it being statutory on the nutrition facts label with its role in health. That it was important to understand if these fibers that are just isolated using the conventional AOAC methods were isolating non-digestible carbohydrates and other things that provided health benefits. And so you don't know that by relying on analytical methods. And there are many different fibers. They have different chemical structures, which then therefore can dictate Their physicochemical effects, such as viscosity and fermentation, and that therefore can dictate physiological effects, which I'll talk about. So, for this reason, and we have a lot of history understanding about the health benefits of fiber-containing foods, and there's a lot of research on individual fibers. There's been hundreds of articles that we've painfully reviewed. But what we didn't know is if those fibers in these fiber-containing fruits, vegetables, whole grains, and so on were providing benefits themselves, with other nutrients, or not at all. And it may depend on the fiber that's in that product. And certainly for synthetic fibers, we have no history at all since they're not in fiber-containing foods. So for that reason, FDA asked the Institute of Medicine to come up with a definition for dietary fiber. They did, and so I'm sure you all are very familiar with this. I won't spend a lot of time on it, but this was the basis for the FDA definition, where if it is an isolated or synthetic fiber, it needs to show a beneficial physiological effect that can't be assumed as it is for fiber-containing fruits, vegetables, whole grains, and so forth. And it's being fairly inclusive by including non-digestible carbohydrates of a degree of polymerization of greater than 3 or equal to 3. So with that, we came up with our definition. It's basically similar to the IOM definition and also similar to the Codex definition. And so this is it. So we're basically saying that, if it's intact and intrinsic, and I'll mention that in a few minutes, and naturally occurring in plant-based foods, then it meets the fiber definition. But if it's been isolated or synthesized, then it needs to demonstrate the beneficial physiological effect. And so, yes, we have a DP3 now of 3 or more. This doesn't necessarily work with some of the older methods if some of these fibers have, as part of them, non-digestible oligosaccharides. And so for that reason, you may need to use some of the newer methods, such as 2009-01, to measure the total fiber if the fiber of interest contains these lower molecular weight non-digestible carbohydrates. So in the IOM report, they talked about intact and intrinsic. And intact meaning having no relevant component removed or destroyed, and intrinsic meaning originating and included wholly within a food. So these are kind of your naturally occurring fibers. And I'll talk about this a little bit more, but this has probably been the most difficult part of trying to understand how to implement this definition into policy, because a relevant component, what does that mean, how much, and so forth. But I'll talk about that in a few minutes. So if it's not intact and intrinsic, in the final rule we gave examples such as lowering blood glucose and cholesterol levels, blood pressure, improving laxation, bowel function, increasing mineral absorption, reducing energy intake. So we gave some examples in there, and I'll talk more about our draft guidance. But it's never been an exclusive list. There's a lot of talk about, well, we just have a defined short list, and that's not the case at all. So in the final rule, we had identified already, up to this point, 5 isolated or synthetic fibers that meet the definition because they demonstrate a beneficial physiological effect, or in the health claim for soluble fibers and coronary heart disease risk 101.81 in 21 CFR, there are some examples in there of fibers that are isolated, and so therefore we said those fibers that are isolated, none of them are synthetic, because they demonstrate a beneficial effect, actually a health effect in reducing heart disease, they also would meet the dietary fiber definition. So to identify new non-digestible carbohydrates that meet the definition, an individual company can submit a health claim petition so that not only are they getting a health claim that meets the significant scientific agreement standard, but it's also at the same time meeting the dietary fiber definition. Or they can submit a citizen petition to demonstrate a physiological effect, which there is an overlap in the endpoints that we would consider for health claims, but it's a little bit more extensive for physiological effects, such as laxation or energy intake. Those aren't endpoints we would consider when reviewing a health claim that's about chronic disease. So since I last spoke last year at the 2016 annual meeting, we've put out 2 additional documents to get the process moving along. And this has to do with how we review the scientific evidence. In the final rule, we had a technical memo that indicated how we were going to review the evidence. And then we have since then published a draft guidance for industry on how we evaluate the evidence. And so all the this was published in November, comments were due in February of 2017, and we've reviewed all those. And there's 2 major categories of this guidance. One is to provide clarification of what we mean by intact and intrinsic and isolated. And so the whole point was to come up with criteria of how one could determine whether they need to have their fiber meet a beneficial physiological effect or not, and what this guidance pertains to. And then also how we're going to review the science. And so, for example, we indicate we're relying on human studies. We wouldn't rely on review articles or articles that aren't providing a full description of the individual studies so that we can evaluate them individually, i.e. primary studies. And then we talk about the studies from which we cannot draw scientific conclusions from, like if there's not an appropriate control group or appropriate statistics, and those type of things. And then the strength of the evidence. What are the factors that we will consider to evaluate the strength of the evidence for that particular non-digestible carbohydrate and a particular physiological outcome? And just to say it now before I forget, only one physiological benefit needs to be demonstrated for an individual non-digestible carbohydrate. So in there, we pose different types of questions that we would ask, such as, are the study subjects healthy, or are they in a disease state such that we can't extrapolate the data from a diseased population that's relevant to that endpoint to the healthy subjects, because the nutrition facts label is for the general healthy population. We also view that to include high-risk individuals. If we didn't, it wouldn't pertain to many people, unfortunately. And so, for example, did it have an appropriate control group and statistical analyses? And these are the basic questions you would ask regardless of what you were evaluating it for. We certainly consider these to be important when we're looking at health claims. And the strength of the evidence. So we're always looking at, well, how many studies they were, but also how large the studies were. Were they, a sample size of 10 or hundreds? And then looking at the outcome and the consistency of the findings. For the outcome, in this case, we're looking at beneficial effect, but of course, there will be no effect. Sometimes adverse effects, not so often, unless the study's actually being conducted. And we have seen these, especially with laxation being the endpoint, to see how much can you consume before you see an adverse effect. And so we're always looking at statistical significance, comparing it to the control group, and then the consistency of the findings. Are all the studies showing one direction, or is it very mixed? Or none of the studies are showing one direction? And then the relevance to the US population. So was the evidence only apparent in a certain subpopulation, and why that might be? Or can we say, okay, well, it's in this subpopulation, but we can extrapolate to the general population? And then the dose, you know, if they're all very high doses, is this relevant to the actual amount of that ingredient that would be added to a food and representative of what the consumer would actually consume? And so we're looking at those type of things. And then we also released at the same time, and comments were due at the same time, a notice to request scientific information. And in this, we identified 26 additional non-digestible carbohydrates for various physiological endpoints. So this was just a summary of the science we collected. We weren't drawing conclusions. Because we can't in a notice to request scientific information. And so we asked, are there other fibers, other endpoints that we may have missed? And if so, please provide us the data. So it was really a data collecting exercise, and it was very helpful because a couple new fibers became apparent to us based on the comments that we received, as well as additional studies, many of them that have been in a foreign language and had not been translated, and so they have been translated to English for us. So the other thing that's happened is that since the final rule was published, is that we have actually received citizen petitions. And so as of June last year, we've received 12 citizen petitions on 9 different fibers. And so as you see, some of them are isolated fibers that have a specific chemical structure, such as resistant maltodextrin, or they're synthetic, such as polydextrose, or they're mixed fiber, such as soy fiber. So we've got a variety that we have reviewed, and the petitions were all nicely put together and providing all the evidence that they could find for specific endpoints. So based on all this information, the comments we received to the draft guidance, to the science review, and the 12 citizen petitions, we have a lot of information that we could pull together to first fix the draft guidance going to final guidance, because that's what you do. You put a draft guidance out, you get comments, and then those comments, we look at them carefully, and if it makes sense, we'll amend the draft guidance to final guidance. So that's standard operating procedure. And so we wanted to get that final guidance done first, because that's going to be how we're going to review the science. And then we're going to evaluate these, all these different non-digestible carbohydrates that came in as citizen petitions or were in our science review already. And there already was a big overlap there in terms of the 26 versus the 9 that came in as citizen petitions. So with all this, then the idea is to update and identify additional dietary fibers that meet the FDA definition. And so, we are working very hard. It's taken longer than I thought, just because there's a lot of layers of review, but we're working really hard to get the final guidance out and a document out that would identify these additional dietary fibers. And so that's where we are there. So in terms of other nutrition regulations related to fiber, this is pretty much not new, so it would be only new if you hadn't seen this or were familiar with the amended regulation. But in terms of soluble and insoluble fiber, there's no changes there. We continue to use soluble and insoluble fiber, and while soluble and insoluble doesn't translate necessarily to a physicochemical effect versus viscous and non-viscous, we do have to have a method for compliance purposes to measure these nutrients or these categories of fibers. And we got numerous comments to an earlier advance notice proposed rulemaking asking about viscosity and non-viscosity and so forth as a physicochemical effect. And it was pretty clear there wasn't a real good way at the time to measure viscosity and then link it to a physiological benefit to understand, well, how viscous does it need to be? So for that reason, we couldn't use those type of terms, even though it would have been nice, because in the real world, we have to be able, or FDA has to be able to measure these things. And so for that reason, we kept it as soluble and insoluble. So, they continue to be voluntary. The daily value did go up a little bit, and this had to do with the adequate intake that was set by the Institute of Medicine of 4 grams per 1,000 calories, and the reference caloric value that we use for labeling purposes is 2,000 kcals. No change in terms of insoluble, non-digestible carbohydrates. It's still 0 kcals per gram, but we did reduce the caloric value of soluble non-digestible carbohydrates from 4 to 2. And if you notice, I say soluble non-digestible carbohydrates. So whether it meets the dietary fiber definition or not, that 2 kcals would work for that because it is a non-digestible carbohydrate without showing a physiological effect. So another nuance in the final rule was record keeping, and we have a number of nutrients where record keeping is necessary, and a couple of them have to do with the units of measure for like vitamin E and vitamin A or folate and folic acid, where you've got a mixture of the form of the vitamin A, and they have different nutritional values, so like dietary folate equivalents, DFEs. So you've got folate and you've got folic acid. They have different nutritional values, but the methods that at least our compliance folks use cannot distinguish that. And the same is true for the added sugars. So you need record keeping if you have a combination of natural and added sugars. And the same is true for dietary fiber. So if you have a mixture of non-digestible carbohydrates that do and do not meet the dietary fiber definition, then you would need to keep records, which I would think companies are doing anyway, to know how much of an ingredient that they're adding to the food. And so because we have AOAC methods that are going to measure this total non-digestible carbohydrate, if we know how much was added that does not meet our definition, then the difference would be the amount that would be declared on the food label as dietary fiber. So this is not unique to dietary fiber at all. So it also affects 3 other nutrients. And then finally, this is the latest thing to come out. Took a while, but it finally did. It's a proposed rule to extend the compliance date for small businesses to January 1 of 2021, and then all manufacturers to come into compliance on January of 2020. So I'll stop there and answer any questions that you might have.
Okay. Anyway, questions?
And please speak
Yeah,
up because I'm having trouble hearing you, John. So I assume I will from the others as well.
Better? Can you hear me now?
Sorry, say something?
Yeah. We have a question coming from Barry McCleary.
Okay, yeah, I can
Hi,
hear you.
Paula, how are you?
Hi, fine, thanks.
Just one question. With the allowed fibers, you have barley beta-glucan, right? Now, we know that the beta-glucan from oats is essentially the same. Would you have to go through the whole evaluation for oat beta-glucan, or could you assume that because of the same chemical, essentially the same chemical compound, it would fly along with the barley?
Yes, so I can't say right now what we're doing, but that was a comment that we received, the equivalence. So, you know, when you have these mixed fibers, mainly plant cell wall fibers, and beta-glucan is a hemicellulose from it's doing all our reading. How do you handle these? So we will deal with that. And so we recognize chemical structure is important where the source is just the source. So I think there'll be a lot of clarity about this when you see our final guidance.
Thank you.
Okay, another question, George?
Hi, Dr. Trumbo, George Salmus here. Thank you so much for that presentation. Really excellent.
Yeah, I'm having trouble hearing you a little bit.
Okay, is that better?
Yes.
Okay, thank you so much for the presentation. It was just excellent. We're all hanging by our fingers, by our fingernails, wondering when's the agency going to be able to come out with the rulings on the dietary fiber petitions and maybe some of the comments that were filed, responding to those.
Yeah, so, I mean, these are the multiple documents that we will be coming out, we'll be responding to the citizen petition letters. But in order to review them, we had to get the final guidance finalized. And so we have done that. And because that's just fundamental to get that done. So when we're responding to the citizen petitions, in one way, they may be responded to when they see in another document that identifies new fibers that they meet our definition. And then if they don't, then we will respond to them. But regardless, we plan on responding to all the petitioners, but this will all come out at the same time as the document that identifies new dietary fibers as well as our final guidance.
Okay, additional questions?
Yeah.
George?
Terrific. That's very, very helpful. You know, one of the things that interested me in particular was the fact that the dietary fibers would be identified by chemical composition, as I recall it. And I didn't see in any of the guidances where that was really drilled into. So are we going to learn about that as the responses come out from the agency, and we'll see how you actually do it? Is that the thought process?
Yeah, I think you will. And I think a lot of it has to do with the fact that, this was kind of a second round where companies or associations should comment. And the level of detail of the comments were so much greater this second time around, really, really specific. And it may be it just had to get that draft guidance out there in these studies to get everyone thinking about, well, where are the complications here? And so we got comments at such greater detail than we got to the proposed rule. And so that was very helpful. And so from that, we're able to move forward and fill in all these gaps and lack of clarity that I understand where that was coming from.
Fantastic. Thank you so much.
Okay, thank you, George. Rajan?
Yeah, this is Rajan Mehta, Paula. Thank you again for the presentation. The question I have for you is, are you going to be issuing a list of approved intrinsic and intact dietary fibers? That's a common question that's asked by a lot of food companies, if there's going to be an actual list. Thank you.
Yeah, so when I said earlier we would be identifying additional fibers, they'll be as a list. So we're just adding on to the list that we already have. I think it's important to also clarify that the dietary fiber definition stands. It is what it is. We're not amending the definition. We're amending the list of fibers that meet the dietary fiber definition. And so when we make any additions, it will be as a list. So that's the plan.
That includes intrinsic and intact fibers, which are not on the list right now?
Oh, intrinsic and intact? Oh, I'm sorry, I missed that part.
Correct.
No, it wouldn't include intrinsic and intact, but we will explain what we mean by intrinsic and intact. And so it'll be very clear, so everyone knows what we mean by intrinsic and intact versus isolated. So it'll be very clear.
Thank you.
I have a couple of questions that were actually emailed to me. As we understand it, total dietary fiber, if you only measure total dietary fiber, it will be included in the total carbohydrates and will be counted as 4 kilocalories per gram. But if we separate it out to insoluble at 0 calories and soluble at 2 calories, the question was, why should not total dietary fiber be listed at 2 calories per gram, since at the maximum, it can only be all soluble dietary fiber.
Well, there is some insoluble fiber that's in products, and so they have a different caloric value. So this really hasn't changed. It's just the value itself. So it's 0 or 2 kcals, where before it was 0 and 4 kcals. And so it's not a nuance, it's just the numbers actually changed.
Right, I think what this person is saying is we missed a point in the regulation that previously total fiber, if you only ran that, was 4 kilocalories per gram, because soluble was 4 kilocalories per gram, and if you had 100% soluble, you got 4 kilocalories per gram. Now, neither of the components is higher than 2, so they're wondering why total should not be 2. So, something to ponder.
If it's all soluble, right.
Well, or even if it's a mixture of soluble and insoluble. See, they don't want to pay for the analysis of both. Okay. Anyway, okay, then the other question that was sent in, and I changed this person's numbers based on your talk today. There's petitions in for about 10 dietary fiber ingredients or sources. And there's about 28, I think you had listed. You said 26 and a couple more had come in. Do the materials for which there are citizens petitions get priority over the other 18 materials?
It doesn't add up that way, because if you look at the citizen petitions and the 26 fibers we reviewed, there are a major overlap. As a matter of fact, there's only one that wasn't part of the 26. So, and that was isomalto-oligosaccharide. So we were already reviewing the other ones anyway. So they're all being reviewed together at the same time.
So you expect the information on all 26 or so will be released all at the same time?
Yes, yes.
Okay, en masse. Is there another question? Okay, I had no more questions. Anybody in the audience? If not, Paula, thank you for your time.
Thank you.
Sorry you won't be joining us for the rest of this. Okay, our next speaker is Joanne Slavin from the University of Minnesota, and she's going to be talking about fiber regulations and demonstrating the physiological effects. Joanne?
Great. I appreciate being here. Thanks for the invitation. And there's a lot of duplication between what I was going to say and what Paula's already said. So I'm going to cut to this as short as possible, because I think the method stuff that's coming up is incredibly important. Here's just my competing interests, people that have funded our research, which I appreciate in the last 5 years, some of the areas we work in, scientific advisory board, and also I do own a farm, and I get USDA payments through that, so I'm pretty conflicted all over. I think it's really important for people to understand, like, eventually we get to regulatory and policy, and it's a really long row. So that 2002 dietary reference intakes, including the fiber recommendations, are based on those blue books, and Paula kept referring to that those are the definitions, that's where we have to go from. So as we go across there, obviously it gets to be a challenge to get there. She already gave you these definitions. I remember fiber is stuff that's in food, so deciding how that is, grains, vegetables, legumes, and some of the physiological benefits, and it's really hard to measure. All of you in the room that work in this measurement area, it's no small feat to figure out fiber in foods. Functional fiber, added fiber, it was originally called. It's anything that is isolated. It can come from plants, it can come from bacteria, it can come from anywhere. It's an isolated, a non-digestible carbohydrate that we put into foods. And these are just a lot of the the endpoint she told you can use as a physiological benefit. So you don't have to show more than one, you just have to show one. And then codex, if you look around the world, there is a lineup on these definitions, and every country is a little different. So remember, these are the US regulations for becoming a functional fiber. What do we agree on? We know it's a positive thing. That's a good thing. It's really hard to measure because it's what doesn't get broken down unlike other nutrients. I think of it as a nutrient because there's enough regulatory there. And right now, going up to 28, the daily value, which makes perfect sense, and it probably should have originally been there, but since this happens at different times, remember, the timelines of this never line up, and that's a frustrating thing for everybody. Everything is based on this data. So this is why people say, how do we come up with 14 grams of fiber per 1,000 kcals? It's based on these large prospective epidemiological studies showing protection from cardiovascular disease as fiber intakes increase. So if you look at the highest quintile of fiber intakes, they're greater than 27 grams per day, you get like a 20% reduced risk of cardiovascular disease. So that's the scientific basis of what our fiber recommendations are based on. So everything translates from that number. There's no UL for fiber, so no reason to not go as high as possible. And I wanted to just mention some of these healthy outcomes or these health outcomes that could be used. And Paula went through them in great detail. You know, the usual ones, the first three that we talked about, but blood pressure. Remember too, like if you go down to number 7, modulation of colonic microflora, other countries, fermentation is being used as a physiological benefit. In the US, it does not count as a physiological benefit. So if you say, well, I got my fiber in through Canada, okay, that's great, but it's not going to go the same route to get it through in the US. One problem in fiber, having spent my whole life in fiber, people eat not enough fiber. So it's kind of frustrating that we're making it harder to put fiber into foods when we really obviously need to do it. Most foods have very little fiber in them. Intakes are about half the recommended level. Fiber is a nutrient of concern, so we don't never want to give up on getting more fiber into foods. And if you just look at where do we get our fiber in the US, it's potatoes and white bread, because that's what people actually eat. So we have to get people to eat foods with more fiber or add fibers into the food supply. Just want to point out the dietary guidelines as we go through how do we get information, how do we support it. Dietary guidelines also support plant foods, foods with fiber, but there's no policy that would say let's add fiber. So, you know, but there's no lack of support for fiber. She's already explained this in great detail, so I'm not going to go through it. These are the ones that are already in, and I want to mention, this is really to tell you how old I am, obviously, but the cellulose paper that was used in that was something I did with Dr. Marlette back in the late 70s. So if you do a study, get it published, it can last forever. So physiological benefits don't go away. So she already talked about that, you know, this where it is in the FDA. And I guess, you know, I have worked with FDA a lot on these, so I think I have a pretty good idea. So if you have questions later, I'd be happy to answer those too. She talked about soluble versus insoluble, so I don't want to go into that. And then just the daily value, and this really does affect a lot of things. If you're a good or excellent source of fiber, if all of a sudden the daily value goes up to 28, at a date, which would be really nice for it to go up at a certain date, obviously based on the discussion here, that will affect those regulations also, and then just trying to figure out calorie values. She talked about record keeping, and this is really frustrating. It's the same for added sugar, and remember, they're doing all these nutrients at the same time. So it seems frustrating from us, from the fiber side, why isn't it done? All these other things have equal challenges are equally difficult. The compliance dates are wrong, and then I just want to conclude and get on to the methods because I think that's really important. Fiber continues to be less than half recommended levels, and the daily value will go up to 28, so then our gap's only going to be worse. So we need to keep thinking about how do we get people to eat more fiber. Every 5 years, dietary guidelines are never going to come out and say don't eat more fiber, so there's no real problem with that. This is a really big change right here. It's no longer enough for an isolated fiber to analyze as fiber. So since the beginning of time, once you measured as fiber, you could be on the label as fiber. Those are new rules. That doesn't work anymore. The date that that's not going to work is, it's frustrating that that hasn't been set, but obviously 2020 is a date that's going to come up really pretty soon. you have to show a physiological benefit to actually take a fiber claim on the new nutrition facts panel. Which is a real challenge, because you can see the number of fibers that are already through is a fairly small number. Physiological benefits are laxation, lipid lowering, glucose control. You saw there, it's open to other things, but it is not fermentation. So that is not an acceptable physiological benefit. That's not to say it's not a benefit. It's not, FDA is just not going to accept that as a physiological benefit. And it's got to be human clinical trials. So as far as mechanism, a lot of what we know, animal studies, in vitro studies, but for these regulations, absolutely has to be in clinical trials. So I appreciate your attention, and I would prefer there are no questions till the, not that I'm scared, but we have 3 fabulous speakers coming up. So after that, I'd be happy to take any questions.
Thank you, Joanne. Yes, we'll have a question and answer session at the end. I think some of us would like to learn more about the fermentation issues and so forth, but okay, the next speaker is David Plank from Medallion Labs, General Mills, and he's going to talk to us about analytical methods for regulatory compliance. Dave?
Thanks, John. And just to correct Joanne, we have 2 fabulous speakers coming, which is Barry McCleary, has a great new method to talk about, and George Salmas, who's an attorney in the regulatory field. And so I'm going to make my presentation a little more brief as well as we go through. I'm going to talk about the new dietary fiber definition, approved methods for determining alternative calories, which we've talked about here, but just to summarize that a little more. Appropriate AOAC and AACC methods and their equivalents for measuring dietary fiber, analytical analyses that can support an intrinsic and intact claim, which I think is a very important piece that George will talk about as well, and then the potential impact of the new regulations on dietary fiber consumption in the U.S. as we see it at Medallion Labs. So the big question that we have is what AOAC method or AACC method will measure dietary fiber under the new rules, and if we're all paying attention to Paula, the answer is none. AOAC methods and AAC methods will only measure non-digestible carbohydrates going forward under the new U.S. regulations, and the determination of whether that non-digestible carbohydrate goes to the evidence of either the physiological benefit or whether something's truly an intact and intrinsic. Paula went through those definitions for us in great detail, and I am going to focus really in on the intrinsic and intact methodologies to support those types of claims. The analytical methods that are recommended under the guidance, they refer to AOAC 2009-01, which is AACC 3245-01, and 2011.25, which is 3250-01, or an equivalent method, AOAC method of analysis, and I apologize for always referring to AOAC, but of course in FDA regulations, that's what is referred to. We need to subtract the amount of non-digestible carbohydrates which do not meet the dietary fiber definition, and this is where we get into the record keeping that manufacturers are going to have to do going forward in order to support dietary fiber claims on their nutrition facts panels. The calories for soluble and insoluble fibers is a key thing. John asked a great question on that. So now insoluble dietary fiber is going to count as 0 calories, soluble 2 calories per gram. John asked what should total dietary fiber count as. I think the answer is because in the Code of Federal Regulations there used to be an allowance for 0 calories per gram for the insoluble dietary fiber. To write over on top of that to include a total dietary fiber definition would have been more of a complete rewrite, I would suspect. And so just adding in the soluble dietary fiber was probably the simplest thing. But the bottom line is that you can only take a alternative caloric claim on your nutrition facts label if you actually do measure insoluble. There is no alternative calories for total dietary fiber. And so you must use the methodologies that will pull out insoluble and soluble dietary fiber. The question is, what are equivalent methods to the methods that are called out in the Code of Federal Regulations? There are the McCleary methods, which are really the standard, and they approach physiological conditions for digest as much as possible under current technology. But you still could use potentially the older Prosky method, which does have some artifacts to it, or the Lee method in combination with the resistant maltodextrins method. The resistant maltodextrins method, AOAC 2001.03, does the same HPLC soluble fiber test that's done in the Codex method. So you can approach the Codex methods with their enzyme digest by combining it with the HPLC test that was formulated in 2001-03. But the thing to realize is that those older methods do have artifacts. They were very non-physiological in the enzyme digest. They were digested at 100 degrees C with a what was supposed to be a heat-resistant alpha amylase. This heat-resistant alpha amylase is actually only stable up to 80 degrees C, and this digest is run at 100 degrees C. And what we find is with certain resistant starches in that methodology that the enzyme is dying off before the non-digestible carbohydrates can be fully digested. Or I should say the digestible carbohydrates can be removed from the non-digestible functions. And so with RS4 wheat starch, we would see a much higher result than we do with the new Codex method, which digests under physiological conditions, and other RS2 and other resistant starches show the same effect. So really these newer methods are getting closer to a physiological measurement of the non-digestible carbs, and what Barry is going to talk about is a new method that he's bringing in that is even closer in physiological resemblance to an enzyme digest. Barry's new method, which he'll talk about, uses a digest that's very similar to the English starch method, which has a high correlation to glycemic response in humans, and is definitely a big step forward. So, as I mentioned, I was going to talk about, what methods do you need to establish an intrinsic and intact claim? Which analytical methods should you use? The first thing to start with for an intrinsic and intact claim is to realize that the fiber must have been traditionally consumed in the U.S. population prior really to 2000. And this comes out of the IOM report, which looked at epidemiological studies to establish the benefits of dietary fiber. So once you have established that piece, is your material still originally included wholly within a food and has no relevant component been removed? And that's where we really can go to a lot of different dietary fiber methods. But one thing to remember that comes out of the dietary fiber definition, lignin, which is not a carbohydrate, is attached to dietary fiber and is included as dietary fiber in the definition. Anything else that is tightly bounded is also included in that. But there's also health benefits that come from lignans. They're powerful antioxidants. And so changes to those is definitely going to change the health benefit of the dietary fiber itself. So the approach for showing intrinsic and intact, once you've met that threshold of being traditionally consumed, is really showing analytical analysis that shows that the starting material before a manufacturing process gives you the same nutritional components after the manufacturing process. So really any analytical method can be used around the approximates and to measure the lignans, total phenolics, the cutin, the waxins, the subrins, all those things showing that those don't change from before processing to after processing helps support that intrinsic and intact claim. And we would encourage documenting that sort of thing if you want to make a claim that your components are intrinsic and intact. Here is a microscopy that we've used to show that actual plant parts are part of the insoluble dietary fiber of a particular sample trying to make this claim. Now, the standard dietary fiber methods don't allow this type of analysis. We do this with our centrifuge method, which we introduced a couple years ago. But it is a good documentation that what you're dealing with are really whole pieces of plant, and that's the basis of intrinsic and intact. So as we move forward at Medallion Labs, we're trying to predict, well, what's this going to mean toward the U.S. population? Will fiber consumption go up with the new regulation, or will it go down? As Joanne mentioned, all around the world, dietary fiber consumption is inadequate. And what we would see with the new regulations limiting the number of dietary fibers that manufacturers can use is that we would predict that the consumption with the new rule is going to actually go down initially. And so we'll actually see probably a frustration of this situation. But one of the nice things about the new regulation is it's pointing out all these new different areas and benefits of dietary fiber that people weren't aware of before. And so now all of these different benefits that Paula is pointing out become new opportunities for businesses and to bring products that address these specific physiological benefits for consumers. And so we would see that over time that the new regulations will drive up new products and new fiber solutions for consumers. And I will skip the summary here and thank you for your time and move on to Dr. McCleary. Thank you.
Okay, thank you very much, David. Great overview of some of the other opportunities available in the fiber arena. Next, we'll have Dr. Barry McCleary, who many of you already know, from Megazyme, who's going to talk about his latest work in methods development. Barry?
Need the glasses. Thanks, John, and thanks, David, as well. You covered a fair bit of the stuff that I might have had to cover. Now, I assume there's one of these buttons moves it forward, so just the big ring. Okay. So this is about development and validation of a rapid codex-compliant method for the measurement of total dietary fibre. In the FDA's terms, that's non-digestible carbohydrates. I'm not going to go into the business of measuring and subtracting because we're all going to have sufficient headaches with that over the next couple of years. I'm just talking about the measurement, the total, and then we'll go on from there. What we see in this particular diagram, in the blue circle in the centre, is what's actually measured with the Prosky method. So most of the insoluble and higher molecular weight polysaccharides, soluble ones, are measured. We measure part of the resistant starch, part of some of the other things. Around about 2000 and perhaps 2 or 3 people decided they wanted to measure these other things like inulin and resistant starch, so methods were developed. But the trouble is, as you can see the overlap, if you measure resistant starch with the resistant starch method and total dietary fibre and add the two together, you get double counting of that overlap. So that's where the particular problem came in, and that's where we got interested in trying to do something about measuring everything, which is that box around the outside. So after quite a few years of work, we came up with a method which we call the integrated procedure, which went through into laboratory studies and became 2009.01 and 2011.25. And the incubations on the left-hand side were trying to match physiology and trying to link in with resistant starch methods that have been published in the 90s and one we published in early 2000. Basically using pancreatic alpha amylase, the PAA, and amyloglucosidase, 37 degrees pH 6. 16 hours is worth noticing. The reason we did that is because most of the resistant starch methods used 16 hours. Now, food doesn't sit in our small intestine for 16 hours. So one of the major complaints we had about this method when we went to fibre is that that time is not physiologically relevant. So anyway, you hydrolyze the protein, you precipitate with alcohol, you get the residues, you measure that weight, you get the filtrate, which is concentrated and measured by high-performance liquid chromatography, and that gives you the measure of the non-digestible oligosaccharides. Now, we call that SDFS, in other words, the soluble dietary fibre that's soluble in the 78% alcohol, and the other one that's precipitated is SDFP, because it's a polysaccharide that precipitates with alcohol. But it became 2009.01, and of course, whenever you put out a method you think is perfect, there's a lot of people come out and say, well, it doesn't quite measure my product. The biggest single complaint was the business about 16-hour incubation, and we couldn't argue about that. So what we did is we looked through literature and
The average time I could see in literature from studies other people did was between 3 and 5 hours. So we settled on 4 hours based on what we got from literature as the time that we needed to go to. And we changed that time to get the samples. The analysis was based on trying to get resistant starch values for a set of samples we had that we had ileostomy data on. So it all related back to the ileostomy data. So we went to 4 hours, and then we changed the levels of pancreatic alpha amylase and AMG to get those values that match with the ileostomy in a 4-hour incubation. And in doing that, what we did is we believe we get a much more accurate value for phosphate cross-linked starches, RS4s. A resistant maltodextrin was produced in the 2009 method. That's not produced, so that's great. And because of the shorter incubation time, you don't have to add sodium azide into the buffer, and nobody likes sodium azide. So you had to for 16 hours because the conditions were perfect for bugs to grow. And with the HPLC, we went to gel permeation away from sugar's water pack because one fraction of the fructans, the trisaccharide, chromatographed and water's sugar pack column as a disaccharide, so it was lost. And a lot of the commercial fructooligosaccharides, that can represent 15% of the product. So you can imagine the people making those products weren't too wrapped in that. That was something we didn't realize at the time, but so we made that change. And because we're using that column, we have to go to glycerol as the internal standard. And in certain cases, glycerol occurs in products, so we then recommend diethylene glycol as a standard. But we can't make diethylene glycol up stable at the concentration we need and supply it over years. It tends to crystallize, so we recommend that if people want to use it, they have to make it themselves. Okay, so looking at the methods, and you don't need to look at all that, but the difference between 2009.01 on the left-hand side and the rin-tin-tin method, as we call it, the RA and TDF method, on the right-hand side is that it's gone back to a 4-hour incubation, and we've increased the pancreatic alpha amylase from 2 to 4 units and the amyloglucosidase from 0.14 up to 1.7 units to get the reaction finished. Otherwise, it's all the same, down to the point where we actually do the HPLC, because we then use gel permeation, the TOSOSH TSK columns. We've also improved the sample handling, so we remove most of the salt in a tube with the resins, then we can inject straight onto the HPLC column with a cation-anion pre-column. And by removing most of the salts in a tube, you increase the use of that D-gashing column by about 20 times. So it actually makes it quite economically viable. Now, we are adding piles more of amyloglucosidase, so the enzyme has to be fairly pure. So if it has any contaminations, they're going to show up. So when you look at these traditional standards we used in the dietary fiber measurements, looking across, you see that the values are pretty much the same, except for the Hylon 7, which is RS2 high amylase maize starch. So we actually get higher values using saturating levels of the enzymes and running for 4 hours. And we have to believe that that value is more correct because this is a more physiologically relevant assay. When we go to the oligosaccharides, again, and polydextrose and things, again, things look pretty much the same, except for the fructooligosaccharides. We're picking up that extra 12 to 15% of the inulinotriose that we lost with 2009.01, and we're getting further hydrolysis of Advantafiber and isomalto oligosaccharides. I'll talk about that a little bit more later. Then we look at a whole range of samples, different sorts of things, and we again see the differences with Hylon 7, we come from 49 up to about 58, so from about 50 to 60%. With FiberSim, phosphate cross-link, we're coming from about 30% up to 60% for that particular sample we analysed, and we believe that that value is correct. That method was published in 2015, so you can see it. We then ran an inter-laboratory evaluation through AACC and ICC. We had 13 laboratories involved from around the world, us being one of them. 104 sets of data, and 4 sets of data showed up as outliers, the ones that are shown on the thing. You know, you're not going to read that, it's just they're different colours so you can see. Ran through the standard statistics. The sample details are there, so they're different sorts of cookies or starches or beans or whatever else. But the key thing is that when you look at the stats with the rapid integrated procedure, the reproducibility and the repeatability across the range of samples is better than any of the other methods previously published. Now, I'm not saying massively better, but it is better, so it's not worse. That's good. So the people that were involved in the study, we had Medallion Labs, Agriculture Canada, us, Food Grain Growers Australia, Sanitarium in Australia, Sudzucker in Belgium, the Food Safety Authority in Finland, two Japanese company, an Italian company, Eurofins in Europe, and Kellogg's company, and also Nestec in Switzerland. So we had a good run of the different types of industrial companies and analytical laboratories. When we put this forward, there was one complaint, and the complaint was that we were not getting the correct values for isomalt-oligosaccharides, and we were still getting too low a value for RS4. And I'd just like to talk a little bit about those. Isomalt-oligosaccharides, we're getting 10.3% with the rapid integrated procedure. If you run the Leo-Leprosky method, you actually get about 8%. And there's a paper published in 2000, and I think there's a year that I can't see it. 2014. Japanese paper where they were looking at the hydrolysis of oligosaccharides using the enzymes from the small intestine of pigs, and they found complete hydrolysis. So I think the value of 10% for isomalt oligosaccharides is probably generous, actually. Then we look at FiberSim, phosphate cross-linked starches. So we had 6 different samples, A, B, C, D, and F. So we ran F as the one we use as our reference all the time in-house. Now, if you run them by the Prosky method, you can see the 85, 86 sorts of values. When you run them by this method, you're getting 14 up to 60%. And I think there's something in the manufacture of those that varies. So they're lower. Now, the thing we have to think about is how is the Prosky method run? And it says to run the assay at 98 to 100 or 96 to 100 degrees centigrade. I think it's 98 to 100 degrees centigrade. So we ran the Prosky method at those conditions and then different temperatures. So we did exactly the same thing but at different temperatures. Running at 100 degrees centigrade, you can see FiberSim we're getting on that one there, the red box up at the right-hand side, around about 75%. But if we go back just 5 degrees, it drops from that back to about 40% or 45%. So it's very, very method dependent on what you actually get. And I think that, and the other thing I should point out is down the bottom there, that in the boxes, I've got the activity of the thermostable amylase left after that incubation. So if you do 100 degrees for 30 minutes, less than 5% of the enzyme's left. So if there's not much enzyme, it's not going to be able to do much. So that's probably the reason why the values are so high. But the right-hand side is just showing the stability of the thermostable amylase at the different temperatures. On the left-hand side, we can see the stability of the enzymes used in the new method, the rapid procedure. Amyloglucosidase is perfectly stable. Pancreatic alpha amylase drops about half over the period of the incubation, but we add twice as much to the assay as we need. So it's twice saturating in the assay, so it's not going to be undersaturating. And the last point, I hope I'm not pushing my time too much, the last point I'd like to raise is that a number of people say, well, you can't use amyloglucosidase. We don't have amyloglucosidase in our small intestine. Well, we actually do. We have an enzyme called glucoamylase, which is one of the activities found on the small intestine mucosa. But we don't have fungal amyloglucosidase. Why is it added? And the reason it's added is maltose inhibits pancreatic alpha amylase. So as the stuff goes through our digestive system, the maltose is broken down by the enzymes in the small intestine and absorbed. In a bottle, that doesn't happen. So we have to get rid of the maltose by hydrolyzing, and we do that with amyloglucosidase. But then the argument is, well, amyloglucosidase also acts on starch. So how do you account for the fact you might be getting over-hydrolysis because of the AMG? And the best way I could see to do this, at least in an experiment, was to use another enzyme that has no action on starch. So the enzyme we chose was a pure Bacillus stereothermophilus alpha-glucosidase. And the main thing to see from this table is on the top part, outside the red box, you've got the standard 1,4 linked oligosaccharides. The enzyme's very stable and very active on maltose and all the other sorts of ones. As soon as you have a 1,6 linkage, the enzyme has no action and it has essentially no action on starch. So in this incubation, you can be sure that all it can do is hydrolyze the maltose and maltosaccharides. It can't touch the starch. So when we did the incubation, if we did the standard, this is a time course, standard incubation with the pancreatic alpha amylase and the AMG on FiberSim, you can see the curve going up, the black one. If we used no enzyme at all, you can see how with the PAA alone, you can see how the maltose inhibits the hydrolysis by inhibiting the enzyme. But if we had the thermostable alpha glucosidase, we're getting mighty close to what we get with the AMG. So in other words, the major action of the enzyme is removing the maltose. And in conclusion, the rapid integrated dietary fibre method, I believe, measures all of the non-digestible carbohydrates or dietary fibre, depending on which part of the world you come from, that are currently available today. Thank you.
Thank you, Barry. And our last speaker for today is George Salmus. Excuse me. For more than 3 decades, food industry clients have turned to George as their lawyer. After graduating from UCLA Law School, George devoted 4 years to Navy service, where as a lieutenant and a JAG officer, he represented the United States in criminal trials in Greece, Spain, Morocco, and on ships at sea. Opening his own law firm in 1985, he focused on the food industry. Under George's direction, the Food Lawyers represents food sector clients in regulatory matters, litigation, and business transactions. Over the years, George has successfully tried a number of litigation members, including a trade secret case, resulting in a $28 million award to his client. George also served as Judge Pro Tem of the Los Angeles County Courts. George's firm also provided the funding for today so we could have Paula Trumbo participate live by 2-way video. Thank you, George, for that. George is going to talk to us about regulatory compliance strategies and class actions. Thanks. George?
Okay. We represent food companies, as John said. We defend class actions. We deal with regulatory matters. We've written citizen petitions for dietary fiber and for comments. So what we're going to work on today is a couple quick strategies for complying with these regulatory rules. Shortcuts, tricks that you can use to get your fiber approved and get moving forward. So we're going to talk about regulatory compliance and hopefully keeping you out of class actions, although if you get into one, we'll defend you. Okay, don't worry too much about taking notes. This is a big picture lecture. It's a 30,000-foot view. The concept is when you're sitting in a meeting or you're working on a project, you'll understand how it fits into the big picture, and that's our purpose here. There are some fine points you should remember, and I'll say this is a takeaway. And I will say, and it'll be identified on the screen as a takeaway, and I'll tell you what it is, and that's something you should remember. If you can't write the takeaways down, give me your card, and on the back, write PowerPoint, and my office will mail you all the slides, so you can kick back now and relax and take it all in. Okay, this is the first one, is just kind of a nuts and bolts thing. When do the new dietary fiber regulations apply to my product? January 1, 2020. Now, FDA changed the rule, not just the date, but how the date is calculated. Before, the date was that you had to have all your old labels off the shelf by this date. So you had to figure out what's my sell-through, what's my shelf life, and you had to be sure that all your stuff was off the shelf by this date. I want to say about a year ago, FDA published it was like a footnote in one of their papers, and they said they changed the rule so that now you can put the current label, the old label format, on your product up until December 31, 2019. So now you don't have to worry about how long it's going to be out there. The issue is just when you put it on the product. I think this is really important. I'm sorry Dr. Trumbo had to break away. I wanted to congratulate her for making something much, much easier for industry than it had been. So this is an important takeaway. And wait, I'm pushing the wrong button. There we go. So this is the first takeaway, all right? That you can put the old format labels on the products until January 2020. Now there's a trick built into this. Let's say that you're having a problem getting your fiber qualified as a dietary fiber. If you have a long enough shelf life with your product, you might want to build up some inventory and have it labeled, because the stuff can sit in your warehouse as long as the label is on the product. It can sit there, you can sell out of inventory, and you might be able to buy 3 or 4 or 5 more months of time to get your fiber qualified. And this is what our firm does. We think up these kind of tricks to help our clients over these rough patches. Oh, I've got a screen down here. This is great. Okay, 2 dietary fiber definitions. The way I like to refer to them is, one is the isolated or synthetic fibers, and those are the ones that go on the list that was been talked about, and the other ones are the intrinsic and intact. An example of that is my client, Grain Millers, their oat hull fiber. That's an intrinsic and intact dietary fiber. So we're going to lay out a couple tricks on how you can deal with these 2 kinds of problems. Okay, first of all, talking about the intrinsic, and I'm sorry I'm rushing, but we're squeezed on time. Talking about the intrinsic and intact dietary fibers in plants. Whether something is intrinsic and intact is determined by the company itself. The company makes that call itself, okay? So what if you get it wrong? Well, Dr. Trumbo will be knocking on your door. You know, you have FDA enforcement, and some of my adversaries in the class action business, they may file a class action against you. So there's some real risk here. And how do we modulate that? So here's takeaway number 2. The way that I recommend to figure out whether it's intrinsic and intact is to convene a panel of outside experts. And here are the reasons. If you ask somebody inside your company whether something is an intrinsic and intact fiber, everybody knows what answer you want. You want the answer to be yes. And that puts tremendous pressure on that person to give you a yes. And if he doesn't have the right kind of experience to get to a yes in the right way, you're going to have a worthless answer. So what we do is we convene a panel of outside experts. The expert, I've worked with Dr. DeVries, Dr. Slavin, and Dr. Jones is here. A bunch of us have been on a bunch of these. Anybody else? I'm looking. I think I caught them all. A bunch of us have been on these panels. David Plank from Medallion. Sorry, Dave. We've all been together on these various panels. The panel does a really rigorous inspection, and they argue with each other, and we get to the bottom line. We produce a report that explains the whole thing. And if you have the names of some of these people on your report and somebody challenges you, their experts are going to know that they're up against it, because they've got the good experts on our side of the table making it work. So that report is like your bulletproof shield. If the FDA calls you, you've already got it. It's already done. If a class action attorney contacts you, you put it out there, and all of a sudden he knows his case is not so attractive, and he's going to move on to softer targets. And that's a big part of class action warfare that we're going to talk about a little bit later, is pushing people off to soft targets. The last thing here is attorney-client privilege, and this is a very powerful tool that we use. I'm sure you've seen on Congress and these congressional hearings where they'll ask some guy a question, and he turns to his lawyer, and they talk, and he turns back to the congressman and goes, "I do not recall." That conversation he had with the lawyer is attorney-client privilege. And the government and the other opposing parties cannot get into that. So a lot of times I can gather information as the attorney, figure out what's good for us and what isn't, and then we put out what's good, and that what's not so good is privileged, and we can take it away and hide it. And that's a good thing, because when the class action attorneys are attacking you, they're trying to find something that you said to use against you. And if I'm screening that stuff out, we're that much further ahead of the game. Dietary fiber definition number 2. This is the one where they're isolated or synthetic ingredients. And these are determined by a citizen petition. You may have heard some of the discussion that was going on with Dr. Trumbo and me about the petitions and what's supposed to be in them. And a dietary fiber petition is a legal technical paper that you file with the FDA and they issue a ruling on whether your ingredient is a isolated or synthetic dietary fiber. Remember the first one, intrinsic and intact, the company determined that themselves, but this one is determined by the government. And so here's the key point that's going to lead up to a takeaway. When you file that petition with the government, you've lost control of your timeline. It's completely out of your hands. Somebody's trying to call me. I was using a timer on my phone. So forget that. Forget the timer. Hell with it. All right. So you lose control of your timeline. On the intrinsic and intact one, when we're producing the report, we work out with the client, how fast do you need this? And then we get it done on time, or usually a little bit sooner. But when you turn it over to the government, good luck, okay? So now here's the analysis. So how much time do we have to work with? They postponed the deadline out to December 31, 2019. That's the last day you can actually put the old labels on the product. So everybody's going, oh, it's 26 months. I got forever. What could go wrong? Plenty. Okay, first of all, let's figure out what has to happen in those 26 months, all right? Let's do this together by the numbers. You got to research and write the petition. I put 2 months. That's Dr. DeVries and Dave and Dr. Slavin and I, we could do it in 2 months, and Dr. Jones, but most people, it's going to take them 4 or 6, but I'm going to be charitable. I'm going to say 2 months, okay? Now, all those petitions that were filed with FDA 18 months ago, none of them have been ruled on. Not a one, all right? So now we're up to 20 months out of our 26 months. Suddenly this isn't looking so good, is it? Now, at the back end, you got to design the labels. You need to have a legal review to make sure they comply with the new law. You got to order the labels from the printer. You got to get them printed. And remember, at this time, everybody else is going to be ordering labels at the same time because the compliance date's coming up. But I'm being a nice guy. I'm saying 4 months. It's probably closer to 6. So there we are. Of your 26 months, you've burned 24. Yeah, and what if you got it wrong? What if your answer is a no? Then you got to formulate product. Or you got to try to file a supplement and you haven't got time to do it. So here's your takeaway. Get started today. Or get started yesterday. And here's the strategy. And I say this to clients all the time. Writing citizen petitions is like playing shortstop. You watch the guys, the Yankees, the Dodgers playing shortstop. It looks really easy until you actually try to do it. And then you're going to be in a world of hurt. So what we recommend is, once again, going to the experts, people that do this on a regular basis. And at the bottom, you see where I put be book smart and be street smart, okay? Well, the experts are book smart. The street smart part of it is that when FDA or an opposing expert sees one of their names on the report, that has credibility, that has impact. And I was with Dr. Slavin on a project one time, and I said to her, I said, Joanne, should we give them the conclusion, or should we give them the conclusion and the option of maybe we'll do some more research? And Joanne said, George, these guys are scientists. They'll always want more research. Don't mention more research, just give them the conclusion. And we did, and it worked. That's street smart. And you only get that with people that do this all the time. So that's an important strategy point. Okay, dietary fiber class actions. As I start this part of it, I want to, in England, they quote Shakespeare a lot of times at the start of a piece. They'll give you a line from Shakespeare, the quality of mercy is not strained, or something is rotten in the state of Denmark. So I'm going to quote, we're Americans, I'm going to quote the American poet laureate of our culture, Yogi Berra. It was, and this is going to come in my presentation. It's Life is a Seamless Web. It was spring training, and Yogi's managing the Yankees, and some of the outfielders are not moving around in relation to the batters. And they're out there dawdling in the outfield. They're not paying attention. So Yogi goes to the top of the steps and yells, "Hey, you can observe a lot by watching." So following Yogi's advice, which I always do, you can observe a lot by watching when it comes to class actions in dietary fiber. Okay, so the basics real quick. What's a class action? You hear about them all the time, but all it is a class action is somebody is suing on behalf of a whole bunch of other people. Imagine that you buy a Toyota Camry and it's got bad brakes. And it costs $300 to fix it, and Toyota says, drop dead, we're not going to do it, okay? So one person can sue on behalf of 100,000 Toyota Camry owners to get the brakes fixed. And when you add together all those $300 claims, it's a big enough pie that you can afford an attorney to do it. So that's all a class action is. A class action is when somebody files a lawsuit on behalf of a whole bunch of people. Now, I want to get you inside the head of a plaintiff's class action attorney so you understand what you're up against. What kind of people, I use that term in quotes, that I deal with on the opposite. We defend companies. That's all we do. In class actions, we're always defending. All right, this is a product. I got my fancy pointer here. Cool. This is a product that is ripe for a class action. I can tell by just looking at that label that it's at risk. And I'm gonna count to one and see if you can figure out what it is. You never will. The answer is some plaintiff's class action attorney is going to take that bag home and he's going to cut it open and he's going to pour the contents on his kitchen table. And he's going to count the number of peanuts and the number of every other kind of nut. And if the number of peanuts that actually come out of that bag are substantially different than what's on that picture, he's going to sue this company for misleading the public because peanuts are so much cheaper than the other kind of nuts, and they're ripping off the public. And I couldn't make this stuff up. There's been lawsuits like that filed, and I'm defending one right now. Oh, and just for the record, no label that I have approved has ever wound up in a class action. All the class actions I defend are labels that somebody else approved. So I'm knocking on wood. So far, I'm batting 1,000. Now, just to prove I'm not making this stuff up. Okay, notice what Planters put on their label. See this? That's why it's there. Because the picture does not show 50% peanuts. But that little statement, it says less than 50% peanuts. So if they've got 49.5% peanuts in that container, they beat the system. And that's why they do stuff like that, because their lawyers are on their toes, and these lawyers are going to get fired, and I'll probably be defending them at some point. But you got to understand, these are the kind of guys you're up against. Okay? These are the kind of guys that want to put their kids in private school and drive Maseratis, the class action plaintiffs' lawyers, based on you doing something like this. All right? And there's lots of money riding on it. Okay, so takeaway number 4. Plaintiffs' class action attorneys are very clever at finding ways to sue you. That's all they do. That's just day and night. Some of them run ads in newspapers. Have you bought some kind of product that they'll identify in the last 6 months? Contact me, and that will be the representative for the class action. I see it all the time. This is a class action that I defended in federal court a couple of years ago. And the claim was overstating dietary fiber on a food label. Overstating dietary fiber on a food label. That's why we're all here. And this is a federal court class action on that very issue that I defended a couple of years ago, and I'm defending another one now. So don't think that if you mess up on your label with dietary fiber, nobody's going to notice. I guarantee you, these guys will notice. And we did a great job on this case, by the way. The client was overjoyed, and I'll explain to you how I did it in a second. Okay, takeaway number 5, follow Yogi's advice. You can observe a lot by watching. Have professionals watch what's on your label. People that do this all the time, because a lot of the cases we get, the regulatory people inside the company said the label was okay, and they don't understand the class action risk. And you're in a much worse position if you get hit with a class action than if you do with the FDA coming knocking on your door over fiber. I can negotiate with the FDA. With the class action guys, they're going to file the lawsuit. Okay, now, these are the dynamics. Remember, this is a 30,000-foot view. I want you to understand the big picture. These are the dynamics of a food label class action. Okay, this is the, attorneys never tell their clients this. I think it's the most important point when you lay out your strategy. No class action has ever gotten to a jury, ever. Imagine you went to a baseball game, and in the middle of the 7th inning, one of the managers comes out and goes, you know, I know it's 2-1 and there's runners on base, but the teams have worked out how this is going to end, so you can all go home. That's exactly it. You're right. No class action has ever gotten to a jury, so we don't know how they're ever going to turn out. They're either thrown out of court in preliminary skirmishes, which I've done that. We've filed motions and gotten cases dismissed, or they get settled. And most of them are settled, but they don't get to the jury. Now, when the case settles, it's great. You defended food companies. Not only do you pay your own lawyers, you also pay the plaintiff's lawyers. You're paying the guys that got into this to rip you off. Isn't that great? Don't you feel good about that, about supporting the judicial system? Or maybe not so much. Now, these are some more key concepts. Remember I said that you're paying both sides, okay? And remember I said no case ever gets to the jury. So what does the plaintiff's attorney know? He knows he doesn't have to file a case that he could win. It's amazing. It just has to be good enough that it isn't so rotten that it gets thrown out of court. That's the standard he's got to reach, of rottenness. All right? If we were, something is rotten in the state of Denmark, something is rotten in the state of class actions. And he knows that if he files this just slightly rotten case, the food company is going to pay him off. Is this great or what? Don't you wish we all had jobs like this? All right, so what is it now? So with all this background about they never get settled, they never get to the jury, they always get settled, et cetera, what really is a class action? Really? It's kabuki. It's theater. Because the plaintiffs on both sides know the longer they stretch this out, the more money they make. And so they go through all these ritualistic dances to stretch the thing out. And the longer the kabuki lasts, the higher the attorney's fees are for the plaintiff's attorney and for the defense attorney. And so they engage in this ritualistic combat where the guy's got, I love this picture. The guy's got the wood, but he's not really hitting them. And this guy's reaching for his sword, but he's not really getting it out. And in the meantime, you're paying for all this ritualistic dancing, all right? So here's takeaway number 6. If you remember anything today, this is the one. If you get caught in a class action, be certain your attorney is dedicated to getting you out as early as possible. That's the key. And we do that, and the reason is because we represent the food company for the long haul. So we're not looking for one quick score. We're looking to do the best job we can for the company in all matters that it faces. And so we have lots of tricks and strategies for getting our clients out early. And each case is different, and there's no one size fits all. And also, to do it, you got to be a law firm that has done it before, so the other side knows what they're getting themselves into. You got to have credibility when you're beating down the bad guys. But this is the key thing is you don't want. We got hired 3 weeks ago by a company in Colorado to defend a class action. And I was explaining the strategy to their in-house counsel, and he cut me off. He goes, George, I used to be a real estate partner at, and he named a big national firm. And pardon my language, but he says, the class action guys told us, it's always the same strategy. You build a shit out of it for 2 years and then settle. And that's coming straight from a guy that was inside one of those firms. So get out as early as you can. And oh, by the way, they hired us and they're happy with our work. Okay. We kind of raced along, but a final word about food law. And I always say this when I give a speech to a group of industry people. Food law is like boxing. Protect yourself at all times. You've been a great audience. Thank you very much. And John, thanks a lot.
Okay, yeah. Thank you, George. I know we've run up against the time, but definitely have some fine speakers here who might be able to answer your questions. Go to a microphone and pose questions. Does anybody? Yes, here comes
I do
one.
have a question about the food law. So I just want to be clear that they can make, when does the product have to be off the shelves?
Perfect question. No one knows. Never, forever. It's driven by your shelf life and really your shelf life, okay? Because, and I read the rule very carefully and I discussed it with the folks at FDA. And as long as the label is on the product before midnight on December 31st on 2019, it can sit in your warehouse and you can sell out of inventory. And there's no rule on when it has to be off the shelf of the retail. It gets off the shelf whenever the shelf life says it's off the shelf.
Okay, so just to be clear, so if I'm making a cracker and the box is out there currently with the old label regulations right now, and that is not, it's going to sell however fast it sells, it's at Walmart, it's, moving along, and then in January, say February of 2020, the older product, that label's still sitting there, but in their warehouse, they have new labels that have been produced, so they've manufactured along the way in 2019. The new labels are sitting in the warehouse, but they're not even at Walmart yet. That's okay.
That's okay.
Okay.
100%.
Okay, another question?
I had a question relating to fiber in terms of the intrinsic and intact. What if it's one but not the other? Is that not counted, or how does that work?
Okay, who wants to handle that? Dave, George? Okay.
I feel like those guys at the rock concerts, they run off the stage and they come back. It's got to be both. It's got to be intrinsic and, the regulation is intrinsic and intact. It's got to be both.
Really? Okay.
Yeah.
Because the reason I asked is because we process post-juicing leftover pumice, and obviously sugar to us is not relevant, but I would consider that not being intact, but it's still intrinsic. So that seems like it's a very specific category, but it seems sort of the intent, not their intent to pull those fiber type ingredients off.
Well,
decks.
okay, you're concerned because the sugar is coming out of the product. Is that it?
Well, yes, because it's been juiced. So
Yeah.
fruit or vegetables that have been juiced, and then that post-juicing material can, people throw it away, but some people process it and then sell that as a shelf-stable, fruit.
Okay, well, I'm going to make a comment, but my professional science colleagues I would defer to them. But, what has to be intrinsic and intact is the fiber, not the whole.
Not the whole thing.
Exactly.
Okay.
So what you need to do, and we can help you with it if you
Yeah.
want, is look at what's left and figure out, is the fiber component still intrinsic and intact? Because if you take off the other stuff that isn't part of the fiber component, you'll be okay. So you're going to need a little bit of analysis. In fact, a lot of my clients need analysis, but that's another story.
Yeah, no,
But the fiber, it could still be.
That was sort of my interpretation, is that since the fiber is still intact, that's the intent of the regulation, but,
The fiber,
thank you.
Yeah, the fiber component.
Yeah.
Okay, don't leave the stage. I have another question. So this is sort of a made-up scenario, but what if you have a plant that's a whole grain plant that has fiber in it, let's say, and that whole plant is chopped up to become an ingredient, let's say, not that, whatever. Can it be a fiber if there's fibers in it?
If it's a plant and you've just chopped it up, chances are it's going to qualify as an intrinsic and intact fiber.
Okay, so there's still a list, right, of which plants are on the list? Is that
No,
what
there's no list. It's just a matter of making that, like I said, making the internal determination inside the company. And I said, hire the experts to tell you the answer.
Okay.
That's how that works. But intact doesn't mean you have to eat a whole kernel of wheat that's never been touched.
Right.
The thing can be chopped up, and the fiber component can still be intact. It hasn't been commutated or cooked into something else. It can be chopped up and still be intact.
Okay, and does that fiber component in it has to be on the list of considered fibers of the 7 that are?
No, it doesn't.
It could be like the other ones.
There's no list of intrinsic and intact. Intrinsic and intact, the experts like Dr. DeVries, we all get together and we make a decision, okay? The list is the isolated and synthetic. That's the stuff that has to be on the list. FDA has to approve isolated and synthetic. Intrinsic and intact, you make your own call, but if you get it wrong, you get sued.
Okay.
Dr. Slavin is throwing me her usual curve. Great question. Yeah, there is a requirement. Thank you very much, Joanne. It's a great question. There is a requirement inside FDA that is not in the regulations. It appears, and they seem to be enforcing it, that the ingredient has to be something that was consumed historically. For most intrinsic and intact plants, that's really easy because you haven't had very many plants added to the food supply. Great point. But that's another consideration is, has it been historically eaten? That's something else you need to look at. U.S., thank you. You knew that before you knew that, yeah. It's eaten in the U.S., that's right. Egypt doesn't help us.
George, a quick question. So if you have a fiber or a fiber material that it has certain percentages of cellulose, hemicellulose, and lignin in the original state, and then you process it and you measure the same amount of same percentage, would that be, considered intact?
Yeah, you're probably going to be okay. Once again, it depends on what the processing is, if there's any kind of chemical change. But if it measures the same way before and after, you're probably going to be okay. And once again, we have to look at it, but first gut reaction. Okay.
Just really quick. Thank you for your presentation. It was very helpful. I was just wondering if you have spoken to the FDA about a specific product that they declared as intrinsic and intact, but they're saying they're not going to publish a list. Do you advise still compiling some sort of scientific committee to approve that as well?
Absolutely. And if you look at, I wrote a comment to the one of the papers that Dr. Trumbull was talking about. I wrote a comment about oat hull fiber, and that's an example of how you should do it. And I was trying to encourage FDA to approve some of the intrinsic intact fibers. And I'm hearing through the grapevine they're thinking about it. But basically the way you do it is you do the report, and then you've got intrinsic and intact fiber. Was that it? Okay, yeah. Thanks.
Okay, any other questions that we can handle while we're here? Okay, I'd like to thank all of our speakers, and for a great morning. We got off to a bit of a slow start due to some technical difficulties that got resolved. So thank you all for coming, and catch me in the hall if you've got any specific questions that I can ask.